Alright, good morning. It's time for shader programming. We're going to make a cloud castle, and I'm going to add importance sampling to my path tracer. Hopefully, at least. One of my issues with this, with doing importance sampling, was I still don't know how to get so for the importance sampling, when you send the light, when you send the ray, okay, basically you add a probability whenever you hit a surface to send it towards the light that's important. It's basically like, for example, 20% chance a ray just gets directed towards the light. It now gives it an importance or a bias, so more light goes towards the light, which is good. It means you end up getting a better lit scene. So you need to know when a surface is pointed towards the light, you can actually almost think of like the probability as like how bright the surface is. So one of the, like, it's actually easy to do for a direct facing surface, but doing it backwards, doing refraction, you can't do, because how much light you get is actually based off how the light bounces around and does caustics inside, which you can't predict. So yeah, I've just decided there's going to be no solution for that, but just having importance sampling will be really good. It's gotta be perfect. It's gonna annoy me. Ooh, that's pretty good. Okay. Hi, Andre. Alright, so I'm going to start with this snow shader, and I'm pretty much going to rip out all of the snow code because I don't need snowflakes or anything. We're just going to make a cube to begin, and we're going to do that to test the importance sampling. So actually we're going to make a cube and a plane. So the cube is length max absolute value. We're just going to make it an even cube. And then we want our plane to go 1 unit down. And then in our material, I think I'm just going to have it all be the same material. And I'm just going to put it in position just right behind the cube. I don't know, maybe I should rotate it a little bit. Yeah, I think I'm going to rotate it around, because if the importance sampling works really well, I should be able to get this in nearly real time. So we're just rotating the ray position and ray direction by the yaw. And this is where I will have to add the importance sampling. Hold on a minute. I actually said before it was easy to get the ray to get the importance sampling matched up with the ray tracing. It's actually not. I hope I did not delete this shader. Wait, I have a warning sign on one of my shaders. What does that mean? There's a warning sign on one of my shaders. What does that mean? Huh. I've never seen a warning sign on a shader view shader before. On a shader toy shader. Wait, let me see this. Shader toy caution icon on shader. I guess I'll just ask the people on Discord about it. This. What does this mean? What does it mean? Why is it here? I can't see anything in the shader. Huh. Maybe, okay, hold on. Maybe I disobeyed a rule of shader toy. Let me see. Terms and privacy. Yep, okay, I have no idea. Who knows? Who knows? Oh, here it is. I think lighting test ground. Oh, yes, beautiful. So there's actually a separator here. Oh, yes, it's perfect. So what this is doing is this is simulating the oh, wait. Is it not copying the light brightness? So this is doing Monte Carlo path tracing on the left. And then it's, wait, which one actually is the Monte Carlo path tracing? That's simulating it. This is the approximation, okay. Weird, it is scaling by light V. Why does the brightness change so much? Oh, is this not scaling by light V? No, this is scaling by light V. Oh, this is doing W times W. So then I need to scale this by like 10. wait, maybe divide it by 10. Oh god, Shader Toy just bugged out there. Alright, let's try it now. There we go. Alright, so basically, given a material roughness and a light brightness, this simulates the lighting of a point. Okay, so on the left is Monte Carlo path traced lighting, and on the right is a Brdf designed to exactly simulate the result of the Monte Carlo lighting, even when it's like reflective. For example, right here, you can see even with the roughness. So what was actually super interesting to me is this is actually just a modified Lambert and Phong. Like, this is actually the basis of Lambert and Phong lighting right here. Is you've got your Lambert lighting right here, and that's used as a basis multiplied by the reflection. Wait, is this even the reflection? Light direction, reflection. Did I even use the reflection here? Hold on. Light direction plus light direction. Oh yeah, never mind. This is completely different. Alright, anyways, this is our lighting for our importance sampling. We now use this as the value, either the value of importance. See, that's the option. I can either choose. What would be most efficient is to actually make this the importance. So this actually becomes the probability. I don't know if that'll create. Yeah, that should work. Let's just do it and try. So first of all, let's set up our simple example. I'm just going to make a sky that all there is a sun. And it's going to be very small in the sky. And I am going to animate it. Oh, we have an error. Oh, this needs to be VEC 3. Oh, I did max instead of min. Of course. Here we go. So actually it's not spinning around. Let's make it spin around. What is up with that perspective on the box? Hold on. Wait a minute. Why is that? Oh, it's just really high field of view. We're just really close to the box. Alright, let's speed it up a little bit. There we go. So what we want to do is we want to make the light really small, like a real sun, because right now this is big, so it's not creating a hard shadow. Here you can see when you make it small, it makes a way harder shadow. But the issue is it gets way more noisy, because the probability of the light hitting that small light is super small. So that's where light importance comes in. So what we do is we put a function in here that randomly reflects the light towards the sunlight. That's like where the majority of the light is going to be coming from. And actually, ideally what we should do is at the end always send it towards the sunlight, but I'm just going to do it with what I know works. So that's the other thing. This is designed for a point light. So I'm really confused. Okay. So this doesn't take distance into account properly. Maybe? So yeah, this is what I was worried about, or what I was thinking about. So it still has the correct Brdf, I believe. It's just not correct brightness. Am I using light intensity anywhere here? No. Okay. So let's see. Making the light position farther away is basically the same effect as making the light size smaller. So making the intensity change. I'm starting to get this. So this isn't taking into account size and distance. Or, so this would work with just a directional light, but this won't work with like a point light, at least at the moment. Let's try something. So as the roughness gets smaller, this actually shouldn't matter, right? Ooh, so that is incorrect now. This isn't still running, is it? No. So let me look at what math this was doing. Light position minus RP. Oh my god, was the light... Wait, where is this sphere surface or whatever? Is this the light right here? Yeah, that's the light. Okay. So when it's 1 unit away, it's accurate. Maybe I should be testing it with a light really far away. Light position minus RP. Normalize. Oh, so it needs a little bit of change. Oh, this is only gonna work with the sphere. Okay, I know what I have to do. I need to set up a new example of this, but with a cube here. This will be a nice project to do. I'm gonna go get water, and then we'll start that. This is probably gonna take me a long time, like a few hours, to be honest, because I'm gonna need to work out. I don't know if I'm even gonna be able to work out what to do here, but I'm pretty sure I can work out something that'll be pretty accurate. All right, hold on. So I'm just thinking how I would do this demo here. Gonna need a new shader for displaying. And then I need another one with, what would I call this? Simulated? Alright, so no animation. This Cloud Castle 2, when it hits the surface here, we're just gonna enable debug at the beginning to make it different. And then right here, display path tracer is, we're gonna change this. Now it's going to I'm gonna check if the mouse is down. Actually, hold on. I'm gonna split the screen between two sides. I'm just thinking how I'm gonna do this. I need to read the two buffers, A and B. And we need to gamma correct both of them. Actually, we need to do this. Slide X. The middle of the screen. If the mouse is down, then slide X is going to equal the mouse position. So then if the UV is bigger than slide X, then we display A there. Or actually we display B, otherwise we display A. And we actually don't need if statements for this, we can just do UV.X, slide X, A, and then that actually still doesn't gamma correct it. Hold on, we'll put them all in A, and then we'll output that and gamma correct it. And I probably want to display a little slider bar, so if UV.X minus slide X smaller than, we'll do 2 pixels, then we're going to display pink or purple. Alright, let's load these in. Perfect. Except I think this needs to be based off of W. Oh, okay. Is how is this code written? I think it's working. Mouse Z is down on the first frame. Oh, the X is 0 to 1. Okay. Or -1 to 1. I did not realize that. Alright. Anyways, that's looking pretty good, actually. So I'm just thinking maybe, yeah, I'm just going to output two different parts of the UV. We'll do one that's -1 to 1. Oh, and then now this is going to need to be divided by screen X. Boom. Okay, awesome. So this is going to be our test of whether or not our Brdf matches up with the ray traced version. So first of all, I just realized I can make this way more optimized and do way less steps, so it'll run faster. Let's turn this off debug and let's do a basic Brdf. So when we get the material and the normal, that's going to be all we need. We're not going to do any background multiplication because the background is black. We're just going to output C. Okay. Actually, we're just going to output C times equals L, and then L is going to equal our lighting. So everything should be white. Oh, never mind. This is still path tracing something. What is this path tracing? This just has the tiny bit of light emission on it. There's no emission in this material, right? No. That's so weird. It's still path tracing. Maybe it's not breaking or something. Oh my god, it's reading from buffer 0. Of course. It's not reading back from buffer 1. There we go. Okay, maybe... Oh. I'm still trying to read from buffer 0. There we go. Alright, let's finally start. Let's go with something simple. I just realized I probably actually don't want a plane because I'm not testing shadows at all. So the goal right now is just going to be to get these two sides to be equal when it converges. And I'm going to start with, right now the roughness is pretty high. I'm going to lower the roughness to 0.01. So yeah, it's going to be shiny. Alright, so we're going to want this little shiny corner right here. That's all we're going to want. I might turn the camera a little bit to try to get... There we go. So that right there is what we're going to be trying to replicate. I don't know, maybe there's a better angle. That's kind of nice. I'm going to go with that. And I might even want to make it smaller. It's like this is supposed to simulate a point light, which is unbelievably small. I don't think I'm actually going to be able to simulate that because it's... That's the thing, actually. If I can figure out a way to do a volume light where it actually has size, even if it's just a sphere volume light, that would be cool. And not just programming, complex programming. I'm trying to get a Brdf that matches perfectly up with the ray tracing. And I'm just starting. There's no Brdf right now. It's just a flat color. I'm gonna begin with Fong. Dot reflect ray position off normal compared to the light direction. Oh, sun deer. Okay, it's backwards. Oh, this is the ray position, not the ray direction. I'm tired. All right. Now let's try applying POW. Alright. It's okay, it's already wrong. Very interesting. So like you can kind of see can I get this to stay? Okay, here we, oh wait, there we go. So you can already see this gradient goes down, or like right here. The path traced gradient goes down way more. All right. Yeah, you can see it does not match up. I actually wonder, I wonder if you make this more of a point light, will it match up more? No, it's still much more of a smooth gradient. Okay, no, I think it's just the way that Phong is calculated, doing reflection right here. But yeah, I'm thinking if you change how the POW, the value of the POW, based off of maybe Fresnel, it could actually warp it to be something like that. Let's see. I also have the tangent and binormals here, so that could be very useful. I'm thinking at the very least, I can maybe try to do like a rough interpolation of two different rays. I don't think that'll give the correct result though. Trying to get the correct, not too bright. So Fresnel is the reflected ray dot product the ray direction, I believe. I honestly can't remember. But let's try multiplying the POW part with that. Let's see how that... Oh my god. Oh my god, it actually kind of worked. So down here, down at the bottom there, where there's that little shiny bit in the corner right here, that's not good, but it's actually lining up. The gradient is lining up. Pog. So let's lower the amount that it does it. Oh my god. Okay. Oh my god, I get it. I get it now. Oh my god, dude. It's so close. Alright, it's still not the correct gradient, but it's really close. That. Ooh. Ooh. Let me let that converge a little bit. Oh, dude. That is so close. That's so close. Okay. That is really nice. The gradient is a little bit different down at the bottom here. This one might just be brighter now. I'm going to lower the brightness. I think I'm happy with this approximation. I think this is alright. There's like a tiny bit more sheen from the Phong lighting right here. But it's pretty good. It's pretty damn good. And I think I can make even less sheen if I want to. Getting the exact lighting values with this is going to be tricky, but I can at least get it pretty close. See, now there's a bit difference in the gradient right there. But it's really close. Okay, I think I'm gonna try to get it to work with different brightnesses now. Or sorry, different roughnesses. So like this is going to completely break now when I make it go to 0.1 roughness. So I somehow need to get it to now match up with this. Or somehow have this based off the roughness. Let's see. Oh, this is actually gonna work. This is actually gonna work. Oh my god. It's like super close. So now I just need to get this function. First of all, I need to attenuate the lighting properly. I'm gonna do that last. And I need to get it to change the roughness. Fucking love working with magic numbers, dude. They're the best. You're not supposed to program like this. adding random values, but it works so well. Okay, so the roughness goes backwards. Let me see if my lighting test ground can help with anything, because I did calculate the roughness in a way. You know what? I should try using this. Oh my god, what is happening on Shader Toy? Jesus Christ. Did you just see that bug when I was selecting it, like, went across? I should just try copying this code. I think I'm just going to try copying this code and see how it works. Oh my god, and I've got multiple of these Brdfs. Which one do I use though? If I remember, I think this one's pretty close. I mean, I'm just gonna try all of them. Selection broken in editing control on many sites everywhere in Chrome. What, really? That's ridiculous. You know what? I'm gonna keep this way simpler and just do this. If this doesn't work, then I'll look at doing my old method. Actually though, this looks a lot like the method I'm trying to do. We'll see. So I need to figure out how to calculate this Phong roughness value from the material roughness. It's probably going to end up being something like 28 minus. Actually, I'm probably going to want to scale this. Times dot product. Times 1 minus roughness. So this is going to be wrong, but let's see it. Sometimes when I see new Chrome problems, I feel like Google will become bankrupt soon. How Chrome can be so bad, I don't know. I don't think Google really focuses on Chrome that much anymore, to be honest. It's like they had giant opportunities with like Chromium and all that. I don't know, it's just kind of like something on the back burner. I feel like it's because it's something they just do for free. Wait, 1 divided by makes it bigger. So I want to make it smaller. So when there's big roughness, this should be low. Okay, divided by 128 divided by 0.1, 2 divided by 0.1. Okay, I'm getting somewhere. Wow, it might actually just be 1 divided by roughness. I think the Fresnel is the only thing messing with it now. Maybe not. Oh, never mind. The Fresnel was helping a lot. Oh, that gives a weird effect. Maybe max. Maybe I don't need the times 0.5 plus 0.5. No. That times 0.5 plus 0.5 is actually pretty good. Maybe just apply POW2 to that. No, now that stretches it down too far. How even are these colors? I should have let it converged more, but 81, 85. Okay, I think that's pretty close. '83 and 82, yeah, okay, that's actually super accurate. Except for down at the bottom. Right there. Except for down at the bottom, okay. So I need to figure out what to do. That's probably better. Still not enough down at the bottom. Maybe this needs to be times 0.5. Oh yeah, that definitely looks more like it. It's too bright now, but I think that's it. Now the issue is going to be, does this work when I change the roughness? Now it's too bright right here. So this would be a good use for machine learning. If I programmed something that looked at the pixel colors and then changed these magic numbers based off these, that would probably actually be better. That's pretty good. Oh, that might be it. Scaled up just a tiny bit. No, it's way darker down there. It is slightly different. Combine two, yeah. Technically this is combining two gradients. It's combining the Phong and Fresnel. I guess I need a third. This is pretty good though. I am pretty happy with that. I'm gonna see how this looks with different roughnesses. I am gonna need to manually change the brightness. To make them even. But yeah, there's no gradient actually at this roughness, so this isn't even like something worth checking. So let's check a higher roughness again, 0.02. I think it is working. The gradients are definitely super close. bugs me how there's that little shining light right there, but I just realized that that is actually probably a shadow, self-shadowing, and that the only reason that this is here is because of, oh my god, that is so close. That is so close. That's really nice. Alright. Let's see if we can get it to like really match up now. Let's do 0.08. Alright, I'm gonna start working on the brightness now, because honestly, this is matching up. There's like a tiny bit difference, like right here. But overall, like I said, I don't need it to be perfect. It's still really nice. Let me try going back to what I had before. Does that look any better? It's so close. Alright, I'm going to start programming this brightness right now. So this is the gradient, which I think is pretty good at the moment. I'm going to keep it at this. And now we need to alter the brightness based off of the roughness. So as the roughness gets higher, it actually needs to get dimmer. So immediately, let's just try dividing by the roughness. I just realized when it gets to 0, this is going to make it explode to infinity, so never mind, that's not going to work. Let's try doing something like 1 minus. What if we did 1 minus 1 divided by? How would I do this backwards? So I'll just do pow. So let's see. At 0.08 roughness, we needed like 0.14. So 1 minus 0.08, 195. POW 100 to do this. Alright, let's see how that looks. Okay, so that gets too dim. Let's see if that carries over for other brightnesses. No, it doesn't. Okay. So a POW curve isn't going to work. Unless I do a POW curve with another POW curve, but I'm going to try something else to begin. I have a feeling that the fall off is similar to this divided by x, but I can't have this explode to a really high value like I can the exponent. So I'm trying to think, like 1 divided by the x will explode to a really high value. How would I do this? Do this gradient of divided by, but have it not go up to a really high value? Like, how would I keep it clamped between 0 and 1? I know I could do 1 plus. Hey, maybe this'll work. Who knows? Let's try it. Alright, that's kind of close. Let's put it up to 0.2 again. Nope, too bright. Try something else with POW again. What if we make it go the other way? Also, 1 here might be too high. I might just need to scale it. So this is times 500. So the base thing should actually be times 500 right here. And then we'll scale it down from there. Actually, times 500 might be a little much. That's how you write one-line functions. Yeah, I started writing it on 2 lines, and then I was like, nah. Then I was like, okay, well then let's separate this right here, and then okay, then we'll separate that right there. So let me try it. When this goes to like 1e negative 8, it should actually technically go up to like 500 because it's perfectly reflecting the sunlight that is 500. Okay. So that's the ray traced. And that doesn't work. And that's way too bright. Okay. Way too bright. Let's try just changing the lighting scale just a bit. Although, yeah, I really want to try to find something that's nearly equal to the sunlight here, but whatever. So let's see what happens when this gets progressively smaller. Okay. Interesting. So I can't tell if that's it getting not as bright or if I think the gradient's actually just becoming incorrect at a small value. Let's just try multiplying by a constant amount again. Yes, I think it needs to be multiplied by like 500. Okay, and the gradient isn't correct now, but yeah, it's very similar. Man, that ray traced effect there, I don't know how you get that type of ray traced gradient. Phong just doesn't capture it, and GGX doesn't capture it either. So yeah, that is now a bit better. Yeah, so actually Phong can totally capture this if you just have the right coefficients. I just need to somehow get this to scale correctly. And let's see if that goes down to even smaller values. Yeah, so this is when it actually breaks down. Oh yeah, so now it's a point light. Now it is a point light. Let's try and make this better. Nope. Nope. Way too much. I think this is limited by light size. So I think what I'm actually supposed to do here is just add a constant exponent, I believe. Or maybe do a maximum. Let's just try subtracting a little bit so that there's at least always... Oh yeah, this isn't going to have a good result. Alright, so then let's try doing min so that we clamp it at a certain amount so that it can't get smaller. Oh, okay, nice. This might work. Oh yeah. Alright. Okay. So this is based off the light direction or something. I don't know, we'll see. So now let's go back to higher roughnesses and let's try and get that working again, because yeah, this is going to be way too bright. I don't think this POW method is going to work, so I'm just trying it really quickly. It might work, might not. Oh wait, it's actually working. Hold on a minute. Alright, nice. It's a bit too bright the moment at this mid section, but so I'm gonna need to clamp this based off of this. I'm not 100% certain. Let's see. Oh, that completely broke the earlier section. Okay. Huh. So I actually don't have a a fix for when the light gets super small like this. Like, I think just limiting the roughness in the importance part is all I can do here, because that's basically what I end up doing to stop it from getting smaller. So like what would end up happening is the light will have a size, but in the importance sampling it's a literal point light where the light doesn't have a size. It's infinitely small, which doesn't actually exist. It's So all I think I'm gonna have to do is just limit this roughness right here equals max, and then technically I think this will have a similar effect to light size. As in if you make this bigger, actually not really, but yeah, it'll help you stop having the light get infinitely small like that, which it's not nice. I'm just trying to find a nice value that's not too small. I think that's alright. Yeah, light actually having size. Alright, let's try and get these colors absolutely correct now. They're actually pretty close, except for right here at the middle, it gets way too bright. I have a feeling that's because I need to use this same scaling system. Wait, where is it? So times 500, then only half the surface will actually get that lighting, which would be 250. Slightly more actually, because the light actually has size. And then we need to fix that via POW scaling, I guess. I feel like this is way too much. Way too big. 200 is way too big an exponent. And I think that this isn't going to work when we get to super small values. Okay, actually it did work. Won't work when we get to more rough, bigger values. Yeah. It's completely dark now. So I need a different way of scaling these. I wonder, what if I apply one scaling method above 0.1 when it starts getting rough, and I apply another scaling method when it goes below? Alright, let me see how 250 looks with really low. Let me even see if 250 is like a correct base lighting value. We're going to make the light really rough, or sorry, not rough, really small. So this actually does look a bit brighter. And what we can do here is we can actually scale this down so we can see how bright the center really is. So yeah, we can actually see here that the Brdf is actually really incorrect. It has a way bigger white line right there. That sucks. I wonder if that line is actually shadowed and that's why it's just brighter here, is because it's not getting shadowing. I totally think that could be it. anyways, that actually does look like a good base value. It's very close in brightness. Maybe just a bit brighter. So if we just put this down to 200. That's probably good. Alright, this intensity part has to be correct because this is kind of going to be key for making the importance sampling not biased. The gradient is actually kind of less important, although it does have the same thing to do with the brightness, but so how do I want to do this? I got another idea. What if I do log on the roughness? And then that should return a negative, I think. And what if we divide by that? I gotta be honest, I'm just trying pretty much random stuff because I have no idea what the gradient's gonna match up to. Okay, how does this work? Oh my god, that's actually really close. Finally. Okay, so that gets way too dim. So I think I am gonna have to have a separate system. One for dimmer objects. Yeah, so this is correct for diffuse. But when it gets to really specular objects, it starts to get too dim. Or it's actually interesting, it gets too bright at the beginning, and then it gets too dim right here. So I have to limit it or something. Let's see. Could just try changing this multiplier. Wait, is this just incorrect? Okay, this is just incorrect. yeah, there's a moment where this just gets way smaller. So I'm gonna limit it right before that, like right there, I think. And this should actually be 100. Yeah, the gradient actually isn't correct here. Okay, I guess I'm still going to be editing the gradient. Yeah, this is going to make the diffuse more diffuse, but I think that's okay. Especially because the light is going to be so sharp. When gradient formula becoming slower than ray tracing lighting. That's the thing, the boundary of where that is pretty damn high. Because the ray tracing a super small light is so slow. Alright, the small still gets way too small, so we'll limit that. Alright, that's looking correct. That is close, it's just not the right brightness. Now that's too dim. Ooh, it's getting so close. Alright, that's nice. Now let's see if it keeps the brightness. Alright, still a bit too bright there. Might need to do POW right here. That's way too dim. Oh my god, a cat. That's not one of our cats. Is it gonna jump up on the fence? I know who that is. I think it... Oh, I think it's gonna go under the fence. That cat's cool because it doesn't even live near here. It comes jumping over like 2 sets of fences to come over here. We got a bunch of catnip and stuff. It's a cute cat. I want to go outside and pat it. Yeah, it's about to mark its territory. Nope, yeah, it's jumping. There it goes. Jumps straight up on the fence. Goddamn ninja. Oh my god, I just realized, knowing this goes to 1e negative 3, I could limit this. Do 1 divided by... one divided by 1e negative 3. Yeah, it's not a street cat. That one actually has a flea collar. Wait, what's happening here? One divided by 1e3 should be like 1000. Oh wait, and then I need some base brightness. Alright, this is a really stupid method. It probably won't work, but let's see. Yeah. So what happens here? This goes to negative 1. That goes to like subtract 1 from there. What if we have it as 1 for this? No, that's still nowhere near. Okay. Oh wait, is it working now? I think it's working. It might be maybe too dim here. The gradient might be, or the diffuse here might be too dim. it's probably a bit too dim. But it's, oh, it's super close. Okay. So now it's too bright there. Okay, so I think I need to have something that kind of lowers this multiplier based off of the roughness. Because this is what makes it look way better when it gets down to like 1e-3. It's actually not bright enough. Alright, well, I'm happy that at least it looks like I'm going to be able to do this, because like at the beginning I said, I wasn't certain if I'm going to be able to actually get this working. But it looks like I am. Wow, I think it's actually good. I think it is actually good. I mean, it's not perfect, but it's pretty much matching up. I think it's a bit too bright when it goes through these roughness stages right here. Oh, it actually becomes too dim right here. Maybe I can actually get it to fix it with low roughnesses like this. Let's see if we can get low roughnesses working. Oh yeah. Okay, there we go. So that actually did make the lower roughnesses look way better. I think I probably just broke it with that though. Maybe not. Actually, that looks pretty good. It's just not bright enough when it goes here. Maybe I'll have to have something that makes it brighter. So this is actually not bright enough. Changing this should make it way... Actually not that much different. I might have to deal with the diffuse just being slightly different. Let me actually let this converge and then I'll measure how different it is. Oh my god, I hate the fact that this blurs stuff outside of the selection. $151, $146. Oh, it's off by just a few units. By just a few units. Alright, let's check close up. I need to make it less bright. So this one's going to be a little bit too bright now, I think. Oh my god, though, I've basically got this. Yes! Alright, yeah, so it's definitely a bit bright. It's so funny how in the one it's not bright enough, and in this it's too bright. $125, $145. Yeah, so this is way brighter. Way brighter. And now let's check. -4. This should be. Oh wait, that's probably too much. Do 1e negative. 0.005. Yeah, we'll do 5e negative 3. Okay, maybe 2. I want it to be just a little blurred. There we go, that's good. So yeah, now it's too dim. Could try this multiplier I had here. Might make it better or worse. So close. Oh, now it's a bit bright. Now it's too bright. Well, I should be able to change this attenuation to be pretty equal. Yeah, I can already see that this is too bright. Just try changing this a little bit till it's just right. That might be nice. And I just want to make sure it stays. Yeah, that's still pretty good. Okay. So what we're just trying to do here is we're trying to make sure this brightness stays the same or nearly the same for all roughnesses. So now, actually, this is a bit dim. And yeah, I'm guessing it's going to get way too dim when we go up to like 0.5. So let me let this converge and then I will test the brightness. But it is so close. So we're within about like 25 out of 255. We're within like 10% color accuracy right now. So that's pretty good. Like I would be happy with that, but I'm a goddamn perfectionist and I want to get like, I think I can get like 2%. So but yeah, you can see here the left side is a slight bit brighter. Dude, my stomach is literally rumbling. Like, I think you can probably hear it on stream. I can see my mic bar moving when my stomach is rumbling. $39 versus 48, yeah, so it's 10 units higher. Alright, 10 units higher. What if we just raise the color a little bit instead of attenuating differently? Raise this to 200, say. This might make it way too bright. Like 0.1, let's test. Oh yeah, I think it's too bright now. It's pretty close though. Yeah, that's too bright. I think. And then it gets too dim. So, I mean, you know what? This might actually be good. Because that's pretty well correct. Let me check right here. I think this is where the brightness is the worst. This is a bit like, I want to say this is like 10% brighter than that. $83 versus 106, okay. So let's try upping attenuation a little bit. And now what I also want to check is, is that too much for when it's high roughness? Okay, that looks really good. So let me check low roughness. That looks pretty good. Okay, I think this is it. Finally. Okay, so that is brighter though. Let me compare this. I don't really care that it's a little bit brighter though. This is pretty good. $100, $114. So it's still it's like 6%, 5%, 6% different. You know what though, I'm happy with that. So this is my thing though. I don't think I'm ever gonna work on this again unless I do another like if I do an actual serious importance path tracer, I'm probably gonna try to set it up, like especially if I do it on the CPU, I'm gonna set it up to figure this stuff out with machine learning. So like in terms of like doing this stuff in GLSL, this is probably the last I'm going to touch this. So it's like I kind of want to get it perfect so then I can just, or as close to perfect as I can, and then just kind of put it away. So that is too bright. Let me just try lowering this a little bit. So now the left side is way brighter. Let's compare these. I think the left side is brighter. $50 versus 44. Yeah, so it's a bit too much. That might be even now. $51.47. Not quite there yet. So I actually know what this needs to be now. I can just, needs to be 50. What is it? 52. We're on. There we go. Perfect. So let's now get this going at other roughnesses. That's the difficult part. So this is now going to be too bright. So I'm either going to need to have it attenuate more. I think that's still a little bit brighter actually. $77 versus 77. Okay. That's actually good then. But changing that probably broke the diffuse. Yeah, so the diffuse should be too dim now. 44, so a bit dark. Still a bit dark. I guess I can try changing the attenuation function here a little bit just to accommodate this. So that's pretty accurate. Let's see. Does it hold up at different roughnesses now? No, I think it's a bit too bright. Yeah, so I think this inverse square root, or just inverse square, maybe that's what I have to do. Maybe I have to change this to square root or exponent or something. Alright, that looks pretty coherent. It's a little bit brighter in the Brdf and a bit less rough in the Brdf. Let's see how it works with the roughness now. I think I'm going to need to make it either attenuate less, or I'm just going to have to deal with it being dimmer. Okay, so that is actually pretty accurate. We're super close at the moment. Yeah, it's just things like this, a little bit brighter. Yeah, I don't think I'm going to get the attenuation working as properly as I want, so I need to think about this. I probably want this specular to be a bit brighter more than the diffuse, if anything, because the diffuse would contribute way more to errors. So yeah, I think this is good. I'm pretty happy with this. It's obviously not perfect, it's not energy conserving, but it's going to make the path tracing way faster. Actually, thinking about it, if this is mainly contributing to diffuse, I might want the specular to be less bright. I don't know, we'll see. Alright. Oh my god. god, I think we've got it. Our BRDF for the importance sampling. There we go. I think I could raise this to make it a bit better at lower roughnesses, but oh my god, I can't stop. I can't stop. Okay, it's good. It's good. I keep fiddling with it going, okay, I can make it a little bit better. I can make it a little bit better. But, no, here we go. Wonderful. So, alright, just like as a heads up, actually, let me just finish writing this first. Oh my god, this isn't correct. I still have more to fix. Okay. So, alright, so like one of my first volumetric path trace shaders on Shader Toy, volumetric fractal path trace. This has importance sampling. That's how it renders so fast. Oh, and I just realized this is broken. The navigation here is broken. Hold on. I can fix this. Maybe. Shader Toy updated their look movement, and it I should actually fix this. I didn't know this was broken. I hate how Shader Toy just updates shaders and then the search doesn't work. Wait, hold on a minute. Oh, here we go. Alright, so this had importance sampling. That's why the shadows here are so quick. Obviously it's still really fuzzy on the first frame, but it fills in super quickly, and that's because the importance sampling just sends the rays straight up towards the light. And the global illumination is actually broken in this because when it sends the light up towards the light, it doesn't check if it ends up hitting the light, so it ends up creating biased global illumination that is more biased towards the direction of the sunlight. And this only works for volumetrics. The hard part I figured out was getting a BRDF that matches your ray tracer, like this, so that like the reflections and everything, not just the volumetrics, match. So that I'm trying to now get the final little things like the diffuse here matching up. And then I'll be able to use the importance sampling for more than volumetrics. And actually, so I have another shader that does importance sampling there, and it only does diffuse importance sampling. It doesn't also do specular / glossy, which I'm trying to do here. So like, yeah, it's really interesting. It's one thing to just do importance sampling. It's another thing to actually have it like be correct and match up with your, like have your importance Brdf match up with your ray tracing Brdf. Yeah, this is too dim, I can already tell. Actually, maybe not when it blurs together. 133, 123. Pretty close. Pretty close, to be honest. I think it might be too bright now that we get down to low roughness. Is it still too bright when it's dim like this? Kind of. Alright, I think I'm happy with that. Let me just see how accurate this diffuse is. It should be pretty accurate. $50, $47. You know what? Yeah, it's basically the same. We got it. We have got it. Alright. So this is the Brdf for the importance sampling for a directional light. I guess I can just do the same thing as this for a point light. That would actually work. I just changed the direction to be towards a point instead of the sun direction. So this is great. Alright, I'm gonna go take a break, go and have lunch. I haven't like stood up or fuck, I didn't even get water through this whole thing, so we can go take a break. And then the fun part, I'm going to apply this importance sampling to the path tracer, and we're going to remake something like the fractal foundation or cloud fractal. We're going to remake something better than that in this path tracer and do like a different shape. Or I have a cool idea of like varying the density of the cloud so you can actually like get light kind of shining through the cloud up above, but then the floor is more dense solid cloud that catches the light as a shadow. I don't know, I got a whole bunch of cool ideas. So that's the other thing. That other path tracer, it actually didn't support variable density. Like I couldn't, right now I can actually do I should actually rename this to volume, start volume instead of opacity. Basically, before I could only have a single alpha value for the whole scene and cloud, but now I can pass in like 2 opacity functions with different alpha values and different anisotropies. Get way better effects. It's good. It's good. All right. I'll be back in like an hour, maybe more. I'll see you over and around. Thank you for watching. If you have any questions about the Path Tracer, I'm on Twitter or Discord. This stuff will also be going up on Shader Toy. I have all my code there, so if you're interested in how any of this code works, my link to my Shader Toy is below. See everyone around. Thank you for watching. Hope you have a good day, good evening, good afternoon, wherever you are. Bye-bye.